Hello students, myself Henasha, Assistant Professor at LG Institutes of Engineering and Technology. Today we are going to discuss few more topics of sequence and series. Let us start with the first topic, that is the definition of monotonic increasing sequence. So, a sequence UN is said to be monotonically increasing if UN less than equal to UN plus 1 for all n greater than equal to 1. That is, we can say that your U1 will be less than U2, less than U3 and so on. So, this type of sequence is known as monotonically increasing sequence. Now let's see a graph of a sequence n square plus 1. So if you are given sequence n square plus 1, so your un will be equal to what? N square plus 1. Now start putting the values of n. Firstly, we will replace n by 1. So you will get answer as what? 2. Now if you put n is equal to 2, you will get u2 as 5 and so on, right? So you can see u1 is less than u2. Therefore, this sequence is monotonically increasing and you can see the graph also, it is a increasing sequence. Now let's see the definition of a monotonic decreasing sequence. So a sequence un is called monotonically decreasing if un greater than equal to un plus 1 for all n greater than equal to 1. That is, your u1 will be greater than u2, greater than u3 and so on. So such type of sequences are known as monotonic decreasing sequence. Now let's see the graph of sequence 1 upon n. So you are given sequence as 1 upon n. So your nth term un is 1 upon n. Now start putting the values of n. Firstly we will replace n by 1. So you will get your u1 as 1. Similarly u2 will be equal to 1 upon 2. U3 will be equal to what? 1 upon 3. So you can see that U1 is greater than U2, greater than U3, etc. So the sequence 1 upon n is a decreasing sequence, right? You can check the graph also. Now let us prove that the sequence 3 upon n plus 2 is decreasing. So let us begin with the solution. Here Un is given as 3 upon n plus 2. Now in order to check whether the sequence is decreasing or not, we will find un plus 1 minus un. So firstly find your un plus 1. So un plus 1 will be equal to 3 upon n plus 1 plus 2, which will give us answer as 3 upon n plus 3. Now let us find un plus 1 minus un. So it will be equal to 3 upon n plus 3 minus 3 upon n plus 2. Now take LCM and simplify. So you will get final answer as minus 3 upon n plus 2 into n plus 3, because this n and n gets cancelled out and 2 minus 3 will give us minus 1. So final answer will be this, which is less than 0. That is, your un plus 1 minus un is less than 0. Therefore, you can say that the given sequence is decreasing. Okay. Now, let's study one more example. Here we have to prove that the sequence n square upon n square plus 1 is increasing. So, let us begin with the solution. So you are given your nth term as n square upon n square plus 1. Again we will find our un plus 1. So un plus 1 will be equal to replace n by n plus 1. So you will get n plus 1 whole square upon n plus 1 whole square plus 1. Now we know the formula of a plus b whole square, that is equal to a square plus 2ab plus b square. So using this we will get n plus 1 whole square as n square plus 2n plus 1 upon. Now simplify this denominator. So you will get n square plus 2n plus 2. Now again we will find our un plus 1 minus un. So replace the value of un plus 1 and un. Now take LCM and simplify. So on simplifying you will get answer as 2n plus 1 upon n square plus 2n plus 2 into n square plus 1, which is greater than 0. So you can say that un plus 1 minus un is greater than 0. So what we can say, that the given sequence is increasing. Okay. Now let us study one more example. Here we have to prove that the sequence un is equal to n upon n square plus 1 is decreasing. So let us start the solution. Here you are given the nth term as n upon n square plus 1. So find your un plus 1 by replacing n by what? N plus 1. So you will get n plus 1 upon n plus 1 whole square plus 1. Now this can be simplified as n square plus 2n plus 2. Now again we will find our un plus 1 minus un. So replace the values of un plus 1 and un. Now take LCM. So on taking LCM and simplifying, so you will get your answer as minus n square minus n plus 1 upon n square plus 2n plus 2 into n square plus 1. And if you substitute the value of n, you will get answer less than 0. So you can say that un plus 1 minus un is less than 0. Therefore, the given sequence is decreasing. Next, let us study bounded sequence. So let us define. A sequence un is bounded above if there exists a number m such that un less or equal to m for all n greater than equal to 1. For example, sequence un that is equal to 5 minus n. Now if you replace the values of n, then you will get as minus infinity and so on, 2, 3 and 4. This sequence will end at 4 because if you substitute 5 in this, what you will get? 0. So this sequence is bounded above by 4. Okay. Next, let us study one more definition. So a sequence un is bounded below if there exists a number small m such that un greater than or equal to m for all n greater than equal to 1. For example, if you are given sequence un as n, start replacing the values of n from 1. So you will get 1, 2, 3, 4, 5 and so on. Here you can see that it is bounded below by 1. Okay, so this sequence was bounded above by 4 and this sequence is bounded below by 1. Now let us study one more definition. If a given sequence is bounded above and below both, then we can say that sequence un is a bounded sequence. Next, let us see one example of sequence un that is equal to 1 upon n. Now here if you put n is equal to 1, you will get answer 1. If you put n is equal to 2, you will get answer 1 upon 2 and so on. If you put n tends to infinity, then you will get your answer as 0. So the given sequence is bounded by what? 0 and 1. That is bounded below by 0 and bounded above by 1. Therefore, we can say that the given sequence is a bounded sequence. Okay. Next, every bounded and monotonic sequence is always convergent. What this statement states? If a given sequence is bounded and also monotonic, that is, it can be increasing or decreasing, then we can directly say that it will be convergent. Okay. So let us study one example based on this. Here we have to prove that sequence un is equal to 2n minus 3 upon 3n plus 4 is monotonic and we have to check whether it is convergent or not. Let us start its solution. Firstly, we will check whether the given sequence is increasing or decreasing. Okay. So let us put our un, that is equal to 2n minus 3 upon 3n plus 4. Again we will find our un plus 1 by replacing n by what? N plus 1. So on simplifying you will get what? Un plus 1 as 2n minus 1 upon 3n plus 7. Now we will find un plus 1 minus un. So put the values of un plus 1 and un. Take your LCM. So on taking LCM and simplifying, you will get un plus 1 minus un as 7 upon 3n plus 4 into 3n plus 7. You can see that it is greater than 0. So what we can say, that the given sequence is increasing, and of course the sequence will be bounded by only two numbers, that is minus 1 and 1 for all n greater than equal to 1, because the given sequence will have maximum value as 1 and the minimum value as minus 1. This you can check by putting various values of n. Therefore, the given sequence is increasing and even it is bounded. So we can directly say by the theorem that sequence un is convergent. Let's see one more example. Here we have to show that sequence un whose nth term is un is equal to 1 plus 1 upon 3 plus 1 upon 3 square plus and so on 1 upon 3 raised to n is increasing, and also we have to check whether it is convergent or not. So let us start the solution. So here you are given un as 1 plus 1 upon 3 plus 1 upon 3 square plus and so on 1 upon 3 raised to n. So what will be your un plus 1? 1 plus 1 upon 3 plus 1 upon 3 square plus 1 upon 3 raised to n. Now we have un plus 1. So plus 1 upon 3 raised to n plus 1. Again we will find un plus 1 minus un. So if you subtract these two, what will remain? 1 upon 3 raised to n plus 1. You can see this is greater than 0. So what can be said? That the given sequence is monotonic increasing. Now we have to check whether it is bounded or not. So again write your un, which is equal to 1 plus 1 upon 3 plus 1 upon 3 square plus 1 upon 3 raised to n. Now we will find the sum of this, because it is a geometric sequence where mod r is less than 1, because the value of r is 1 upon 3. So the sum will be equal to a into 1 minus r raised to n upon 1 minus r. Now put the value of r, and a is 1. So you will get 1 into 1 minus 1 upon 3 raised to n upon 1 minus 3. Now simplify this. So what you will get? 3 by 2 times 1 minus 1 upon 3 raised to n. Now as you take n tends to infinity, you will get limit n tends to infinity 1 upon 3 raised to n, which will go to 0. So finally your un will be less than 3 by 2. Right? So we can say that the given sequence is bounded above by 3 by 2. Therefore, our sequence was monotonic increasing and also bounded above. So directly from the theorem we can say that it is convergent. Okay. So next is our sandwich theorem. Very important theorem. So let us start with its statement. If we are given three sequences un, vn and wn such that un less or equal to vn less or equal to wn for all n, then what we can say? If limit of un and wn is equal to n, then limit of vn will also be equal to l. So what this theorem states? If the limit of these two sequences is equal, then limit of vn also will be equal to what? L. So let us start solving few examples. Here we have to discuss the convergence of the sequence un is equal to n factorial upon n raised to n. So let us start with its solution. So you are given un as n factorial upon n raised to n. Start putting the values of n. If you put 1, you will get answer as 1 factorial upon 1 raised to 1, which will give us answer as 1. Similarly, find your u2. So u2 will be what? 2 factorial upon 2 raised to 2. So 1 into 2 upon 2 into 2, and so on. Un will be equal to 1 into 2 up to n upon n into n. So rewriting this expression, we will get what? Un is equal to, we will take out 1 upon n common, 2 into 3 into n upon n into n. So what we can say from this expression is that the given thing will go to at most 1. So finally what will be your un bounded by? So un will be bounded from 0 to n. Now as we take n tends to infinity, we know that limit n tends to infinity, 1 upon n will be equal to 0. Therefore, this goes to 0, this also goes to 0. Therefore, what we can say? Limit n tends to infinity, un will be equal to 0 as n tends to infinity by sandwich theorem. Therefore, we can say that the given sequence is convergent. Okay. Next, let us discuss the convergence of sequence un is equal to sin n upon n. So let us begin with its solution. Here un is equal to sin n upon n. Now we know that minus 1 less or equal to sin n less or equal to 1. Now we will divide this by n. So on dividing you will get minus 1 upon n less or equal to sin n upon n less or equal to 1 upon n. Now let us find the limit of these two sequences. So what we will get? Limit n tends to infinity, minus 1 upon n will be equal to 0, and limit n tends to infinity, 1 upon n will also be equal to 0. So limit of these two sequences are equal to 0. Therefore, by sandwich theorem, we can say that limit n tends to infinity sin n upon n is equal to 0, which is a finite limit. Therefore, we can say that the given sequence is convergent. Okay. Next, let us discuss the convergence of the sequence un, that is equal to cos square n upon n. Let us start with the solution. Here we are given our nth term as cos square n upon n. Now we know that 0 less or equal to cos square n less or equal to 1. Now divide by n. So what you will get? 0 less or equal to cos square n upon n less or equal to 1. Now let us find the limit of this quantity. So limit n tends to infinity, 0 will be equal to 0, and limit n tends to infinity, 1 upon n will also be equals to 0. So limit of these two things are same. So by sandwich theorem, limit n tends to infinity, cos square n upon n will also be equal to 0. This is a finite limit. Therefore, we can say that the given sequence is convergent. Okay. So in today's lecture, we have studied three types of sequences. So first is monotonic increasing, right? Next is monotonic decreasing. So in order to check whether the sequence is monotonic increasing or decreasing, what we will find un plus 1 minus un. If un plus 1 minus un is greater than 0, then we can say that the sequence is increasing. And if it is less than 0, then we can say that the sequence is decreasing. Now next we have studied bounded above sequence, right? So when we can say that the sequence is bounded above, if there exists a number m such that un less or equals to m, then we can say that the given sequence is bounded above. Next we have studied bounded below sequence. So if there exists a number small m such that un greater than or equal to m, then we can say that the given sequence is bounded below. Next we have studied bounded sequence. So when can we say that a sequence is bounded? When there exist numbers small m and capital M such that small m less or equals to un less or equals to capital M. And if a given sequence is monotonic and bounded, then what we can say? That the sequence is what? Convergent. Fine. Lastly, we have studied a most important theorem that is known as sandwich theorem. If we have three sequences un, vn and wn such that un less or equal to vn less or equals to wn, and if limit n tends to infinity un is equal to limit n tends to infinity wn is equal to L, then what we can say? Limit n tends to infinity Vn is equal to L, right? So I hope you understood throughout the session. Thank you for watching.